Okay, hello everybody. Today we're going to talk about section 10.1, part 1. We're going to still graph, and we're going to graph a different shape today, something we haven't looked at or done before. We're going to graph an ellipse. An ellipse is an oval-shaped graph. Okay, you guys graphed circles in geometry a couple years ago, and we're going to review circles later on in the year as well. But an ellipse is similar to a circle when you graph it and some of the characteristics and how you do it, but the radius isn't the same around the whole shape. An ellipse represents an oval because the horizontal radius is different length than the vertical radius, which causes an oval shape. So the radius is not consistent, making a circle. Rather, the numbers you're given make it have one radius, a horizontal radius, different length than the other radius, which is a vertical radius. So it results in an oval shape. Now, the ellipses we do here in part 1, all of them are going to have a center at the origin, 0, 0. So we'll start off simple, and we'll add some stuff as we go. And they'll all be centered at the origin. So just for example, like the general image or shape you're going to get, center at the origin, and you might get an oval that looks like this on the graph somewhere. Here, the vertical radius longer than the horizontal, or something where the horizontal radius is longer than the vertical radius, center at the origin, something like that. All right. Sometimes if both radii are very close together, it might almost be a circle, but not quite. All right, so that's what an ellipse is. Now, here in the box is your standard generic ellipse equation. All right, the equation looks like this. You're going to have a fraction plus another fraction equal to 1. Okay? These are pretty much the same equation. Just A and B are here. Over here, you have B and A. Don't really worry too much about A and B for right now. But here's what you're going to have. You got two fractions equal to 1. You're always going to have a plus sign. All right, so when you have an ellipse, you're adding the two fractions, okay? You're not going to see a minus sign right now. A and B are going to actually be numbers, okay? So these are going to be numbers, not the variables A and B, but you will have the variables x and y. So in the numerator of each fraction, you're going to have an x squared or a y squared. You're going to have that. And the denominator is going to be a number, okay? So x and y on the top of the numerator being squared, and a number on the bottom, okay? And a 1 on the other side. Now, right here, you can get rid of that. We don't need to, I put this here because we were going to differentiate between the numbers A and B, but we don't have to do that today. But one thing to note about A and B is that both are going to be positive. You're not going to have any negative signs anywhere. Otherwise, it's not an ellipse. It's something different, which we'll talk about at another time. So you're going to have a positive fraction, positive numbers, everything, a plus sign, and another positive fraction with positive numbers. And you're always going to have a 1. If you don't, you have to get the 1, which we will cover in a little bit. All right. A couple other things. One thing you will be doing is you're going to have to take the square root of whatever numbers A and B are in the denominator. All right, so this is an important step we're going to take in a little bit when we do our examples on the back, when we graph them. You have to take the square root of A and B, because what that gives you are your 4 main points that we're going to need to graph. Okay, when we graph these, we want 4 main points. Those main points are our intercepts. 2 on the x-axis, 2 on the y-axis. Let me show you. 1, 2, 2 on the x-axis, because you got to know how far to come out. And then 3, 4, 2 on the y-axis, because you got to know how far to go up and down. If you get those 4 points, 2 on each axis, you know how far to come out of the center, and you know where your 4 points are, and you can graph your ellipse or oval. All right? One last thing. If x has your bigger denominator number, that means the x-axis this way is going to have the bigger radius. So it's going to be stretched out more this way. So it will kind of be like an egg lying on its side. Or like a potato or something, I don't know. If the bigger number is under the y, if y has the bigger denominator number, then it's going to be stretched out more in the y direction, up and down vertical. Because that means your radius in the y direction on the y-axis is longer. So your oval will be more stretched out up and down. That's a bad looking oval, but you get the idea. Okay, so that's something to keep in mind when we do these. All right, let's go ahead and hit the back and look at our 4 examples. All right, so we're going to graph each equation. And this is how you're going to do it exactly on the notes as well. All right, so remember on the front side it says we have to take the square root of the bottom numbers. So this is nice and easy. These are perfect squares. Square root of 36 is 6. Square root of 25 is 5. You'll see that it fits the equation. You're adding, and you have x squared y squared on the top, numbers on the bottom, and it equals 1, so you're good to go. So that's what an ellipse equation looks like. Now, here's what these numbers tell us. The 6, which is the square root of 36, tells us the radii the radius from the center in the x direction is 6. This 5 tells us the radius in the y direction coming out from the center on the y-axis is 5. That's how we get our 4 points to make our oval or ellipse. So now we can we can draw our XY axis. All right, so remember, these are all centered at the origin. So in the X direction, come out 6 both ways. 1, 2, 3, 4, 5, 6. And then negative 6. All right, and in the Y direction, up 5, down 5. So x-axis, y-axis, you have your center, you have your 4 main points. You got to show those 4 points on the homework. And now you can make your oval. And try to make a decent oval. Don't worry about how perfect or non-perfect it looks. And there you go. Now 6 and 5 are close numbers, are not far apart. So this might look more like a circle than an ellipse. That's okay. 6 and 5 have a difference of 1. The closer the numbers are, the more it will look like a circle. Okay? All right, number 2. All right, here we go. Same type of equation. It equals 1. And we have x squared y squared on the top. Numbers on the bottom. Plus sign in between, so we're good to go. All right, square root of 4 is 2. Square root of 9 is 3. And we're going to pretty much do the same thing we did in number 1. 3 out in the y direction from the center. 2 out in the x direction from the center. And we can make our ellipse. So we need, in the x direction, go to 2 at least. In In the y direction, 3. And you can put your points. And there's your ellipse for number 2. All right, now you'll notice in numbers 1 and 2, we didn't have to change or manipulate anything in the equation. We didn't have to divide or multiply by anything. We didn't have to move anything around. Sometimes you have to do that. So let's look at a few like that. All right, number 3. Now this does not fit the generic ellipse equation. You don't have a 1 on one side. You don't have fractions on the other. But to get the 1, to have it equal 1, you have to divide by 100. That will give you a 1 on the right. Well, if you divide this side by 100, you got to divide this entire side by 100, which means you divide both of these by 100 each. So we put 100 underneath to divide by 100. Now you're going to simplify. 100 over 100 is 1. Keep your x squared, y squared up top, but you can easily reduce these nice. 25 over 100 is a fourth. You don't have to write the 1, so x squared over 4. And 4 over 100 is 1/25. You don't have to write the 1, so it's y squared over 25. Now we've got the equation we want. And now we do it just like we did numbers 1 and 2. Square root of 4 is 2. Square root of 25 is 5. And now we're ready to get our 4 points. So x direction is going to be shorter. So in the x direction, out 2 from the center. In the y direction, out 5 from the center. And there we go. And one last problem, one last ellipse, number 4. All right, this one you have to do a couple more things than you did in the first problems we did. First of all, x and y aren't on the same side, so you have to move this over. You have to add 5y. That'll give you your plus sign that you want. That's good. We need that. 35. And then, like we did number 3, you don't want 35 there. You got to divide everything through by 35 to get that 1. All right, so reduce this like we did in number 3. So this will be 1/5 or x squared over 5 plus 1/7 or y squared over 7. All right, now it looks like the generic equation we want, and we're ready to graph. Now when you go to graph, you don't have perfect squares. When you go to take the square root, you can either leave it as a square root of in radical form, or you can get decimals. Making these decimals might be easier to approximate. It's up to you. Square root of 5 is about 2.2. Square root of 7 is about 2.6. So if you want to make them rounded decimals, you may, and just approximate, that's fine. All right, so here we go. All right, so this is between 2 and 3, so we have to probably take it out to all right, you can just approximate, guys. It doesn't have to be perfect, but I do want to see your 4 intercept points. So in the x direction, just a little bit past 2 each way. And in the y direction, about 2.5, a little bit past 2.5. 2.5. And then once you have your So this would be 2 and 3, 2 and 3. And then you can make your ellipse. And that, guys, is how you graph an ellipse. If you're given the basic equation, you can take the square roots and go right into it to find your 4 points. Or you might have to, like we did in 3 and 4, manipulate the equation a little bit, move some stuff around, divide through to get your 1 and to get your fractions. And then you can take the square roots to find out how far you come out of the center point. All right, guys. Y'all have a good rest of your day, and thanks for listening. Bye-bye.